So why I did not I told you guys that I didn't cover these topics in my previous batches, right? And almost all of them are placed. And if at all, in worst case scenario, unfortunately someone did not get placed, it's certainly not because of circular or doubly linked list. My point being, it's nothing on its own. This doubly linked list, circular linked list, it's just uh, utilizing the same concepts as that of a linked list. That's why I don't really, I didn't used to teach it. I taught it this time because it was you can say given in the structure, mentioned in the structure, and I thought it's good only because doubly linked list, circular linked list, these items just improve your understanding only, right? So there's no harm in studying that. So anyways, that's my take. But still, you guys are the customers. If you are having any problem as a shopkeeper, my responsibility is to satisfy you to the best of my abilities. So basically, if you are having doubts in circular and doubly, we can take out some extra time, okay, on weekend, and we can solve that particular case, right? Acha, before that, I can just quickly create a poll where you can tell me if you guys are comfortable with keeping a class on Sunday or not. Like those who are comfortable, that's fine. But those who are not, some people mentioned that I'm busy on Sunday. But like my question is, you would be busy in some particular slot only, right? And if there is only one person who is busy, or maybe uh, like fewer number of people, then maybe we can just have it there. एक second now. The poll banana is a very difficult task for me, very time taking. I'm launching this poll. Okay, so you can tell me if you guys are comfortable having a class on Sunday or not, and then based on the numbers, we can take it up. Let me just tackle the other, read the other doubts till then. Arey, haan, sorry. Thank you. Camera, right? Uh, yeah. Binary search by 3-4 days. Yeah, but Varun, my point is doubly circular or whatever is actually a sub part of linked list only, right? So I won't say, I won't comment on the importance or anything, but yeah, 99% of the questions you will see on singly linked list only. Singly linked list is the linked list which has a single pointer, the next pointer only, right? Linked list, see, so someone asked which topics are most asked in the DSA interviews. All the topics that we are covering in module 2 are non-negotiable, right? Like if I say binary search is important, linked list is more important than binary search, and then stacks is more important than linked list. So it's like it's a loop kind of thing. Every other topic is more important than the other topic, right? So this is a very special module. I can't pinpoint any particular topic. Ki binary search is more important than linked list. All these topics are immensely important, right? Let me HR session is there, but after that we are free only, right? And the good thing with HR session is it's informative, but it doesn't like require any special cognitive. It doesn't give any load to our mind. यहाँ पे तो अपन को ध्यान से दिमाग चला के सुनना पड़ता है. That's a this is a heavier task, right? There you just have to focus on what they are saying and keep notes, note their point. It's just about uh, what I'm trying to say is it's easier to understand, right? So that should not be an excuse of not keeping a session on Sunday because this is important, right? अगर है लिंक लिस्ट में दिक्कत, we have kept 5 lectures on linked list, 2 before me, 3 with me, right? Then also we are having doubt. That means we need to like remove that problem, right? So we need to give extra effort. Otherwise, like generally 4 lectures, 3 lectures, theory wise only 1 lecture is enough for linked list, right? So if we have a special problem, we will have to resort to special solutions as well, right? So that should not be an excuse. But still, I'll just take the poll once again. Those who are saying they are busy, I'm planning to keep it in the morning only. But that morning has actually turned to afternoon. So I think you have your HR session because of that. We have a slot from 12 to 2, 12 to 3. That slot we have. So I'll take the poll once again uh, in the like towards the end of the lecture. Agenda for that day will be solving linked list questions purely. Okay, so you will have some assignment questions given to you for the weekend, and you will also have some contest you have tomorrow. So all that stuff we can discuss in that class. Plus these miscellaneous doubts, right? That if you are not clear with circular or doubly or whatever, right? You can also ask these doubts to. There are live doubt sessions, and there are your this doubt session that just happens from 8 to 9. There is chat support also. So utilize those resources as well, because I told you lecture time is something that we need to use very wisely, right? So having said that, let's start with the agenda today. Today's agenda. Okay, so binary search is a new topic first of all, and it's a very important algorithm. Just a second, let me pin myself. है ना? The device is not working. Huh. So we are going to start with binary search today, and let's keep your thoughts about linked list on hold for some time. हो जाएगा, okay? Do not worry about it. It's not anything special. From my side, I am saying if you're comfortable in making a node, if you're comfortable in all the code that I wrote on IntelliJ on my computer, right? I told you insert, delete, all that stuff. If you're comfortable with that, हो जाएगा सब. If you are not comfortable with that, then I should hold a mirror in front of you guys. I will not sugarcoat this. Then it is a problem. Okay, and then you need to work on it, because we have already taken the other person also took linked list lecture, then I also started it from scratch, and if it's still an issue, then there's something wrong. So we will anyways work on it, but just drop those thoughts now. Let's, with a fresh perspective and a fresh mind, let's start binary search. And very easy, very easy, very intuitive, right? But very important also. So this algorithm is I think we hardly study algorithms in DSA. I mean, so far you have studied in module 1, you studied a lot of algorithms, recursion, sorting. This is one other algorithm, binary search. But from this point onwards, you will only see data structures being introduced, stacks, queues. Then you will have trees and other stuff, right? So this is one of the most important algorithms that you are going to come across. Okay, so before I directly tell you about a binary search, let's I think all of us know what searching means, right? The point is why we study about searching separately is because, take a very basic example, like when you do a Google search, like what are you calling it? You are calling it Google search, right? So whenever you are like in your day-to-day life also, you use the search operation widely, okay, like in a very significant manner. So search is a very important part of everything that we are doing, right? Similarly, in computer science also, searching and optimizing the way we are searching is also very important, right? A very basic example that you can take, again I'm repeating, Google search, right? So thousands of results load in a fraction of seconds, right? Whenever you Google something, it says above that some 1 billion or a very huge number of results loaded in 0.81 seconds, something like that. So all this is happening because of a lot of other things. But what I wanted to tell you was how important searching is. So with that thought in mind, let's talk about trivial ways of searching, and then we will move to binary search. So let me take an example for you, okay, to establish what we are going to study today. So I'm going to take a random array 1, 8, 2, 9, 4, 6, 0. Array ended here. Okay, so like this. Now if I ask you to search for the element 9 in this particular array, the point is we don't have any pattern here, we don't have any special you can say uh, pattern in which the numbers are occurring. So what we will have to do is we will have to go to every element, knock there and see what's the value. If the value is same, we can say okay, we found the element. If the value is not same, we will keep moving on. Basically we will keep doing an I++ and search for the other elements in our array, right? So what we will do is we will start from this number, or you can say this index, right? We will check the number here, right? We will see okay, 1 is not equal to 9, so let's move on. Then we will come here, move on means I++. Then we will come here, what do we see? 8 is not equal to 9, so let's move on. 2 is not equal to 9, so let's move on. 9 is equal to 9. So let's print the output, or maybe take out the index or break the loop, whatever you want to do, whatever the question is asking you. The point is, when you reach this particular element, you can say that, okay, I found this particular number. So the code will look something like this, right? You will have a for loop ranging from I is equal to 0 to n minus 1, right? And then inside that you will have a logic like this. If arr of I is equal to, let's call this number target, then maybe you can return I. Okay, so let's assume that we are working on a function that returns the index of the element you want to search. Okay, because there is no pattern here, this is the only way we can go about it, right? This is the only way we can go about it, because there is no particular pattern of optimizing the search. So we will have to consider every element, and whenever we get lucky, we will just move out of the loop. That's the only approach we have. So is this thought clear to you? This trivial approach is called as a linear search. Why linear? I'll tell you why. But we are moving across each element, right? We are not applying any special trick or any special thought, right? And why linear? So can you observe that this particular process will take O of n amount of time for you, or basically the time complexity is going to be O of n, right? So this is simple operation on array, right? I mean, this is something that that could have been asked to you just after you completed your pre-course only, like even before module 1, right? Swapnil, what have we been doing for the last, you can say, 2 weeks? All those questions are real questions that have the potential of coming in the interview. You know, a lot of doubts in counting operation using binary search. I don't know about counting operations. I don't know about binary search. So let's keep it on hold. Okay. So Swapnil, maybe you can just clarify it better. But the thing is, all the questions that we have been doing, all the assignments that you have been doing, right? They are actual interview questions, right? I'll tell you my case in a company that I was selected for, not my current company. What I was asked was, I was asked to implement linked list. Like, how below can they go? Like, what's more basic than that? They could have just asked me my name and my hobbies and just let me go. They asked me to implement linked list. Okay, and I asked them, why are you asking this from me? I mean, I've come for a job role that's going to give me exposure to writing applications that real people are going to use. What is this like make a linked list? He told me that people don't even know this. Okay, there are people who don't know how to implement a linked list, because what you do is, in lead code and in other you can say places, you just directly write the code, dot next this temp not equal to null, whatever, return answer, whatever, right? So I was surprised there, and that's something that you should be thankful for, because see, in AccuJob portal, each time you are taking input, you have to build your linked list from scratch. So as compared to other people, as compared to people like me who were prepared in a different way, right? We were never told how to write a linked list except for once in the lecture class, right? Luckily, I remembered it because it was not something special. But with you, the good case is you see it daily when you are solving your assignment questions, when you are solving questions in the class, when we are solving it on the portal. You construct a linked list from scratch daily. So it's something like regular for you now. So if someone comes and asks you to make a linked list, you will also laugh at them the way I considered that particular interview. And then he went on and asked other difficult questions also. So that's a different thing. But that's how the interview started, and it was done in that way. So whatever he was asking me after that was just to, you will realize it. आपको इंटरव्यू में समझ में आ जाएगा कि मेरा इस कंपनी में हो गया है, right? And then they will just kind of push the limit for you just to see till where you go, right? So that was to answer your question, Swapnil. There is no, it's not that if a question is easy, it cannot be asked in interviews, right? And we have solved difficult questions also. So all these questions that we have solved, including the theory, are all probable candidates for coming in the interview only. So everything is in that way. Still, I will find and give you some more questions, so don't worry there. Okay, so this is linear search. The way you can search, if a random array is given, you can just keep traversing through the whole array, stop where you find the number and just return. So, and it is an O of n operation. That's also one of the reasons it's called a linear search, linear time complexity, right? Now, this is the only way we have if the numbers that we have in our array are in a random order, right? The numbers here are in a random order, right? 1, 8, 2, then 9. So basically 2 is lesser than 8, 9 is greater than 2, then 4, 6. Numbers are arranged in a random manner. So there is no particular trick that you can implement here, right? So this is the only way to go about it. There is a special condition when the numbers are sorted, or let me just say array is sorted. So now that your array is sorted, it will look something like this: 1, 2, 4, 5, 8, 9. Right? This is how your array is looking now. Now if I ask you to search for 8, you might still say that I will, go here, keep moving till 8. When I find it, I'll just return. That's still valid, right? I mean, if something is valid on a random array, that's definitely valid on a sorted array as well. So linear search will work. But the drawback is it will consume a lot of time. What if your 8 was present here towards the end and you had more smaller numbers here? That would have just consumed more of your time. So then, thanks to our ancestors, whoever did this, whoever thought about binary search first, because when I'll tell you about it, you will say it's nothing. But I don't know how difficult it would have been to come up with something so basic and so useful for the first time. So the idea behind binary search is, before I go there, just let me ask you one question. If I say that whatever number I'm searching for is greater than 4, whatever number, whatever it is greater than 4, is it telling us something very important about the array? Is it not telling us that if it's greater than 4, we can directly discard this side of the array and we can directly head towards this side? Okay, so now our problem, in which we had to search for 6 numbers, now we only have to search for 3 numbers. What if I tell you that my number is less than 9? So now you only have to search for this side of the array, because 9 and whatever numbers you had there which are greater than 9 are also going to get discarded. Because if some number is lesser than 9, then it's definitely lesser than 10, 11, 12, 13, right? Numbers that are going to come after 9. So basically, that is the principle on which binary search works. And in each iteration, the idea is to somehow reduce the size of window, right? Let's see how we are going to do it. So once I explain this, I'll again open the chat for you, and if you have a doubt, you can just ask it there, right? So, and let me just do it here only, right? Let me just remove the clutter. Okay, we have this array. Cool. So this is our array, right? Let me also add one more number. So this is your sorted array. Now the number you are supposed to find is 8. Okay. So the idea behind binary search is, let's go to the middle of the array. Okay, I'll tell you why middle. Let's go to the middle of the array and then see if our number is greater than the middle or lesser than the middle. So let me apply that for you, and we will discuss further. So this index is 0, 1, 2, 3, 4, 5, 6. This is the index, and the logic behind calculating the middle element is, or you can say middle index, is generally like this: left plus right by 2. So if this is when I'm starting the question or when I'm starting the search, I'll be considering the whole array. So this is the left bound and this is the right bound. So this is the L, this is the R. Okay, now what I'm going to do, calculating the middle like this, is equal to 0 plus 6 by 2. So I'm going to come at this particular element. Okay, now the binary search starts. Okay, now the logic starts building up. You have reached a particular element which you are saying is the middle of the array. Now what you will do is, you will compare this number with the target that you are searching for. Okay, this is what you want to search, right? 8 is our target. Let me just write it properly. Your target number is 8. That is what you want to search, right? Now, what you realize here is I am at a particular element which is lesser than 8. Now, the question you need to ask yourself is if my number, or you can say, if my number, target number, is greater than this particular middle element, is there even a need to consider all these numbers? That is what you need to ask yourself. Okay, so if 8 is greater than this 5, not only do we need to ignore this, we can safely ignore this particular segment also. Whatever is coming to the left of 5, because those numbers are going to be smaller than 5, and 5 in itself is smaller than our target, right? So now what we need to do is we need to shift the window, or we need to compress the window by saying that okay, now this is the window that I will be considering. So this is where my left iterator, or you can say the starting point, is going to point to. You can you can do it like this. Okay. So is the idea getting clear to you? What is it that I explained? If my middle element is lesser than that particular number, there is no need to go and check all the numbers that are to the left of it, because they are definitely going to be smaller. Why? Because the array is sorted. So let me open the chat for you now. And are you clear with the idea so far? How binary search means to search? How does it work? No, don't go on the literal meaning. Binary means, why binary? We were breaking the problem into half at each step. You will realize later. That's why we are searching for the middle element, right? You are taking the middle element. So that way the advantage is either the left side or the right side is going to get completely tossed out, right? So that's how you are just dividing the problem here, right? Most of you, all of you are clear only. Okay, sir, please turn off your camera. It makes some disturbance. Others sir also did the same. Maybe different. Sometimes we see you, but not the thing you are teaching. Okay, there is an option on Zoom where you can actually turn off the incoming video. So in that way, Vipul, if let's say you have some bandwidth issue, you can turn off my particular incoming video for yourself. Okay. So I personally turn it on. I didn't used to turn it on before. We were instructed to do so. So that's why I'm doing it. And I believe that it makes the lecture more interactive. So you can try that approach. Okay. So no issues. Your feedback is clear. But yeah, if it is sorted, yeah, only then. Binary search is only applicable for sorted arrays. Yeah. Then only you can basically confidently say that if it's greater than 5, it's going to be greater than these elements also. अब sorted नहीं होता, यहाँ पे 9 लिखा होता. So then that way there is no advantage, na? There is no pattern that we are able to establish. So binary search, definitely we are only going to study for the sorted arrays, right? That's the first condition. That's why I said when array is sorted, only then let's talk about this particular concept. If the array is random, just you can't apply any other search other than linear search. Go and knock at every index, see if the element is present. If it's not, close the gate, move on, like that, right? Okay. Okay, so now this is the point where we have reached, right? One element we have found out, this particular one, right? And we said that let's analyze if it's lesser than 8 or it's greater than 8, our target element. This particular one is lesser than our target element. So we just said we can completely ignore all these elements. So we moved our starting iterator and we moved it to what? Let's say this was our middle element. So we kind of moved it to middle plus 1. Right, that's what we did. Now let's see what's the remaining picture. So let me remove the clutter. It's not actually cluttered as such. So yeah, let me just take this particular part. 8, 9, 12 we have, right? 8, 9, 12. This is the remaining array we have, and the index is 4, 5, 6. Index is 4, 5, 6. This is our L. This is our R. Left and right. That's why I took these names. Okay. And target is still 8. So let's continue. What is the logic? Let's calculate the middle element. 4 plus 6 by 2, 5. Right. So this is our middle. And okay, what do you observe this time? This time the target is actually lesser than our middle element. What does it say? Our middle element is greater than target, so that's definitely useless. But also, because our middle element in itself is greater, that means all the elements to the right of it are also going to be useless for us, right? So that's also something that we observe from here. So can you say that we also need to ignore this segment now? And what we need to do is we need to bring our pointer, or you can say our the iterator that's denoting the end of subarray. This particular item we need to move to this place, which is actually middle minus one, or you can say one position left to middle, right? Because middle is useless and all the items that are to the right of it are also useless. So we need to consider from the position which is just to the left of middle. Are you guys comfortable with this thought? Let me open the chat again, right? Okay. Okay. Aniket, raise your hand, please. I'll unmute you. Yeah, Melvin, nice intuition. Recursion can be used. We will use recursion, but क्या बोलते हैं? While loop is also very easy to use here. It's very good that you identified that recursion can be used here, right? Yeah, Aniket, what's your doubt?
Hello, sir. I didn't get the mid minus one.
Mid minus one. Okay. So what I'm saying is, this is the picture in right in front of you, right? So what I'm saying is, this is the array that you are considering. Sorry, this particular portion you are considering, right?
Yes.
Now you're calculating the middle of the array. Why? Because that way the advantage is using the you can say relationship of our target element with middle. You can directly ignore one side. जैसे कि if our middle is greater than the target, in that case क्या होगा? Because middle is greater,
Yes.
that means all the elements which are greater than middle, that is all the elements which are to the right of middle, are also going to be greater than a target. है ना? So that
Yes.
the advantage that you got was you just in one step to reduce the problem to half
Yes.
by ignoring the irrelevant part, right?
Yes.
So okay, now you know that what part we need to ignore. This part we need to ignore. So which
Yes.
part do we need to select? The part which is just to the left, just one position to the left of of middle,
Yes.
right? Because middle might be irrelevant, but just one element to the left of it that can be useful. We're just
Yes.
trying to reduce the problem size, right? So now that's why I said this is what you will do.
Yeah.
Right?
Got it. Thank you.
So yeah. So in this case, as you can see, now if you calculate the middle, what will happen? The reduced problem now becomes you only have one element to consider, and you have both L and R at this particular position, and as you can see here, target is also equal to 8, right? So what you will do is middle again. Middle is equal to what? This is index 4 actually, right? So, and I think you can guess here, L and R are both the same values. So this is going to be the middle element also. What is the middle element in an array that only has one element? That element itself, right? That's pretty straightforward. So what you are going to do here is this the element you are looking for? Yes, it is the element you were looking for. So you will simply, whatever, you will print the answer, you will return the answer, you will say that, okay, this element is present in my array. Whatever you want to do, you can do at this point, right? This is binary search. Okay. So let me actually create a poll, right? So that we can just keep reusing that. Create one. ये क्या है भाई? Okay, whatever. So I'm just relaunching this class on Sunday poll, but what I actually mean to ask you is if you are clear with the particular concept or not. So I'm just reusing that because I don't know. I'm not getting the option to create a new poll. Is the concept of binary search clear to you guys now? Do we only check for greater or lower? Anam. So good question. We also check for equality, right? But I didn't tell you that because I just wanted to take these particular cases. Definitely we check for equality because ultimate target is that only. We want to search for the element, right? So yeah, nice observation. Yeah, we check for equality. Okay. So now that we are clear with this particular concept, there is one more thing that I want to tell you. I took a very easy example where I said that okay, the target element is present in the array. Let's see what happens if our target element is not present in the array. That's also possible ना. Search करने वाला तो कुछ भी search करेगा, है ना? Okay, okay. Anyways, so 1, 2, 4, 6, 5. Sorry, sorted है ना? 7, 11, 13. Okay, index 0, 1, 2, 3, 4, 5, 6. Target फिर से 8 ले लेते हैं because it's not present in the array, right? So now see, let's see what happens. Okay, so target is 8 and let's start our, हमें तो एक ही चीज आती है, left right लेंगे, middle से we will try to break the problem into half. Okay, so let's do that. Middle is equal to 0 plus 6 by 2 is equal to 3. So basically I didn't write it, but because we are starting the question, we are given the whole array, so we will consider the whole array in the first time, right? Because we don't know where our element lies. So this is the left and this is the right iterator, and now we are going to start our problem. This is the middle. What you observe here is array of mid is actually lesser than 8, our target. So what we want to do here is, we definitely know that this is not the answer. Also, all these elements now become irrelevant because same thing, right, that I explained earlier. But I do need to search for all the elements which are after here, because if my 8 exists in the array, it is definitely going to come after the middle. So what I will do is, I want to start searching from the right of middle. So the way of doing that is to increment, or you can say to assign my left pointer correctly. To assign the pointer, or you can say pointer, I am saying it's just an integer iterator, okay, don't get confused. So to assign this particular iterator the correct value, because this particular iterator is going to denote the starting point, right? So L is equal to middle plus 1, because if at all 8 exists in the array, this is the segment where it's going to exist. Okay, so L, this way we will just update it, right? Now the reduced problem is 7, 11, 13. This I'm just doing to make it visually like more intuitive for you. Okay, real question में array तो रहेगा ही अपना, right? It's not going to magically disappear or anything. Don't have thoughts like that. This is 4 index, index 5, index 6, and this is L, this is R, target is still 8. Okay, now let's start again. This is the middle, this is the middle, right? And now what you will do is, I just showed you the middle, and even if you calculate 4 plus 6 by 2, it's going to give you 5 only. So this is the middle. Now what you observe here is array of mid is greater than 8. That means this element and all the elements to the right of it are useless. So your way of representing this information is by saying, let's mark the end of our sub array just to the left of middle. That is, yahan tak ki array consider karte hain. After that we don't need to go. Are you getting this point? So R will now come here, or you can say R is equal to middle minus 1, as I pointed out earlier. So what you have here is, you only have this particular portion to consider, right? You only have this particular portion to consider. And if I write down here 7 at the index 4, this is where left is pointing, this is where right is pointing. So it's basically saying that this is the subarray where we want to consider, and which is actually just one number, and target is what? Target is 8. So what you do here is, you will again calculate the mid. So mid will come out to be this number only, and here you will see array of mid, which is 7, is what? Lesser than 8. And what are you trained to do? If you observe that array of mid is lesser than 8, what do? All the elements to the left are also going to be irrelevant. So your intuition is to set the range correctly. So now you want to start consideration from the element just to the right of mid, right? क्योंकि mid के just right से बड़े element start होंगे and mid तो छोटा है 8 से. So what you will do here is L is equal to mid plus 1, and you are not wrong in doing this. But in this particular case, when you are making this movement, just see what's happening. L will be moved here to the index 5, and what I want you to observe here is L has crossed R. L has crossed R. What it means is, let me disable the annotation. I forgot to do it. What it means is that L is greater than R. Let me stop and share again because that will stay on my screen otherwise. Okay. L has become greater than R. That means I have covered my entire array. And even then I have not been able to find this particular element. Right? Why am I confidently saying that I have covered my entire array? Because at each step, all we were doing was to reduce the problem set and go and make it more relevant to our search, right? If we found greater elements, we ignored them. If we found smaller elements, we ignored them. And now that we are coming here, and now left is becoming greater than R, what it means is left is actually going to a portion that R has already rejected. Do you agree? So what does this mean? When L becomes greater than R, there is no valid subarray anymore that you can search your target inside. So whenever this condition occurs, that means element not in array. Okay. Is this thought clear? Let me relaunch the poll. Is this thought clear? When we will not have the element in our array. Okay, today we have a good conversion ratio, right? Cool then. So this is all about your binary search. If you ask me about theory, we are done. Okay. Any doubts till here? I will take 2 doubts. Raise your hand. First come, first serve. If you have doubts, है ना? बाकी if you don't have, बढ़िया. Someone raised, हाँ. Yeah, Prince and Ritik.
Yes, sir. Can't we just put the condition as if L greater than or equal to R, then return element not in array?
वही तो करेंगे. But तब तक तो चलाना है ना logic. So what we were seeing earlier was till before that point, when L was less than equal to R. Till that point we want to run the logic, na?
Yes, sir.
So as soon as that gets violated, after that we will end, right? So
yes,
it's
sir.
like just picture that we are running a while loop with this particular condition, not this condition, with this condition, L less than equal to R, है ना? And as soon as this gets violated, we will come out of the while loop. If we have come out of the while loop, that means L is not less than equal to R anymore. That means L is greater than R. Just return element not found or whatever, right?
Just the same with if we use recursion.
हाँ. Recursion में भी same thing.
This case would be same if
L. Yes, it is. So recursion में it would be more like we will even we will consider solving the case if L is less than equal to R. Yes. Otherwise, we will not even solve.
Yes.
That's how it will happen, right? Yeah. Meet. Go ahead.
Yes, sir. Am I audible?
Yeah.
सर हम लोग इसमें लिनियर सर्च का अगर यूज करें तो फिर इस बाइनरी सर्च के मुकाबले उसकी तो टाइम कॉम्प्लेक्सिटी कम होगी ना?
अरे मैं बताना भूल गया टाइम कॉम्प्लेक्सिटी. That was the main point why we have introduced binary search. नहीं भाई, binary search बहुत ही छोटा प्रोसेस है. It's less than O of n. That's my bad. I directly jumped to asking. Sorry?
हाँ सर, because array सॉर्ट का भी यूज होगा एंड बाइनरी सर्च का भी यूज होगा, तो फिर टाइम कॉम्प्लेक्सिटी ज्यादा नहीं हो जाएगी?
सॉर्ट किसने करने को बोला है? सॉर्टेड है।
ओके ओके सर।
है ना? अरे ये मैं बताता हूँ आप लोगों को। थोड़ा टाइम है, एक डाउट और ले लेते हैं, फिर वी विल मूव ऑन। या विपुल?
Hello, sir. Am I audible?
हाँ, यस यस यस।
Sir, as we found that we should perform this on the sorted array. So if we are not getting the input as sorted array, then we should have to make it short. Nah.
See, so two answers to your questions. If
Yeah.
your only intention is just search, right? I'm muting you because it's causing disturbance. If your intention is only to search or perform basic operations, and someone is giving you a random array, unsorted array, in that case we will not go and sort the array, because sorting in itself will take more time and effort than linear search. But if we can get some advantage by sorting the array and putting binary search in it, then we will use sorting from our end. Okay, so that's the point. There are questions which go to n square if we don't if we just start solving in the unsorted array. But if we sort them and apply binary search or maybe some other concept, then it becomes n log n, because sorting is n log n, right? Arrays dot sort function. So it depends on that. If you're supposed to apply basic concepts, searching and maybe searching the insert position, all that stuff, there is no need to sort the array by yourself. You will only perform binary search if the operations are easy and the array is already sorted. है ना? If you have a complex problem and sorting and applying binary search is giving you lesser time complexity than the brute force approach, then you will go about it. ठीक है ना? So in general you will not be sorting array on your own. है ना? So now let me tell you why binary search we are studying, right, in the first place. I forgot to tell you, I should have told this to you earlier. Binary search gives us a time advantage, right? If you see at each step, tell me if you agree with this, we're considering if this is our array. I'm not writing an actual array because I just want to explain the time complexity to you. If this is our array, this is the point we are considering. Based on the fact whether array of mid is less than our target or is greater than our target, we are doing something. Either we are rejecting this portion or we are rejecting this portion. Either way, like in both the ways, are we not reducing our problem size to half? So if you had n elements to consider at first, in the next time you will have n by 2 elements to consider, right? And then you will have n by 4, n by 8, and so on till you finally you can say converge at one element, till L becomes equal to R, right? Till that point you are just breaking down your problem, right? Also, that's first observation that I want you guys to make. Second observation is, in this process of selecting the relevant subarray, so this is what is happening, right? I am breaking the problem into half. But this process of breaking the problem into half, how much time is that taking? So if you see carefully, I am checking this condition, I am checking this condition, and I will check a third condition. If my array of mid is actually equal to target, then I will return, finish the question, right? So I'm not considering that as of now in the discussion part. So either this or this, both these are simple logical operations which are going to get completed in O of one time. Okay. So if you carefully see, what I am doing in this particular question is, I am in O of one time, I am breaking the window into half. I am breaking the array into half till we converge at one particular element, right? That's what I have been doing. Now the real question is, I am performing this O1 amount of effort. How many times am I doing that, right? So number of times. The number of times I'm doing this breaking the array into half into O of 1 is going to become my time complexity. There is no calculation like that, but I'm just trying to give you an intuition. So basically the time complexity will be number of times you are breaking it, right? How will we get to that number? We have one condition, right? You will keep breaking it till you have one single element, right? So I think by now all of you must have guessed that it's a log of n case, because it is taught when we teach basic time complexity. But if you still haven't guessed, it's like you have n, you break it to n by 2, then you break it to form n by 4, and you will keep doing this till you finally get 1, right? So Adarsh must have told you it in this way: for I is equal to n, I greater than 0, I is equal to I by 2. ये लूप देखा है आपने? पहले I होता है, फिर I by 2 होता है, फिर I by 4 होता है. He must have told you that the time complexity is log of n to the base 2. ऐसा कुछ discussion हुआ होगा if you have discussed time complexity. If not, the logic behind that is mathematical, and the logic is, first of all, two things you need to do. First thing that I want you to do is to intuitively think, does this process seem smaller than going from n to n minus 1 to n minus 2 to n minus 3 and so on till you finally have one element? So it's like saying, when you are starting to search in the array in a linear fashion, first you have n elements to consider. After you have considered one element, you have n minus 1 element still left. Then you still have n minus 2 elements. Then you still have n minus 3 elements. Then so on and so forth. You will ultimately reach the last element, and then you will conclude that whether my element is present in the element or not. So can you intuitively feel that this particular approach seems better? And the second thing is a mathematical calculation. So this is what you have been doing, right? So n, you're dividing n by 2, right? You're doing this particular operation, and you are doing it, let's say, k times, right? So first you took n, you did n by 2, and then what did you do? You did n by 2 by 2. Then when you got n by 4, you did n by 4 by 2. So basically you are essentially doing n by 2 k times. So n upon 2 to the power k, and you will keep doing it till you reach 1. So mathematically this boils down to not n, k becomes equal to log of n to the base 2, right? That is what happens. I'm sure others must have discussed this example here, and if you know this, there should be no problem in identifying that this is the same thing happening all over again. And instead of writing I specifically, I just directly wrote it, right? So are you clear with the idea of time complexity of binary search? How we are breaking the problem into half at each step, and breaking the problem into half only requires O of one time. So now the problem is, how many times are you doing it, right? है ना, आदर्श ने करवा ही दिया था. So we are doing this particular operation log of n times, right? That's why our time complexity finally for binary search also becomes log of n, right? Yeah, Praveen, go ahead. Yeah.
My doubt is, if the length of the array is even, then which index we need to take as a middle of the element?
I'm not getting a problem. Which index?
Which index we need to consider as the middle if the array of the length is even?
Okay. So that's also pretty straightforward. The idea is you can take any one of it, right? So what we generally do is, by this calculation L plus R by 2, what happens is, if you have 4 numbers, 6 numbers, let's say, these 2 items are eligible for becoming the middle, but by this calculation, this is the number that gets selected. Okay, so good question, but I hope it answers your question, right? समझा ना Praveen?
Yes.
Okay, great.
Got it. Thank you.
Sure. Yeah, go ahead. I'm not able to identify Afashas. You can unmute yourself. Yeah, what's your name?
My question was the same question as the previous one. What if
Okay,
you
okay,
have
okay.
even number of elements?
Okay, okay, sure. But yeah, tell your name also.
Pardon?
What?
It was answered.
I'm not able to
Hello?
understand. What's your name? I'm asking.
My name is Isaki Afash.
Okay, okay. Isakie Afar. Good. Okay, glad you got it. Yeah, official account. Go ahead. Okay, yeah, Chirag, go ahead.
Hello, sir.
Hello.
Yeah. Yeah. Go ahead.
Hello.
Yeah.
Yes, sir. If we have an array like 1, 2, 3, 4, 5, 5, 6, and we need to find 5, then there are 2 5 present in the array. Then how binary search can do in that format?
Binary search will give you any random 5. Okay. Let me simplify it for you. 5, 5, 5, 5. This is your array. Your target is 5. Your middle is 5. That's how it will happen, right? So when you have multiple occurrences of a same number and it is still sorted, then it will give you any random 5. You don't have any control over whether it will give you the first 5 or the last 5. Okay, there is a different way of achieving that functionality, and that we will cover later. Okay, so good question. We will cover it. Okay, Devendra, okay, let me just take this doubt for Devendra, and then I can just stop it.
Hello.
Yeah, go ahead.
Am I audible, sir?
Yeah.
Sir, suppose we have duplicate present of the target what we are looking for, then what we'll do, sir?
We will handle that case separately, but if you ask what this particular approach of binary search will do, it will not care about whether it's the first occurrence of that duplicate or the middle occurrence or maybe the last occurrence. It will not care about that. It will just, as soon as it finds that, it will just return that answer to you. Okay, our current approach. Okay, so
Okay.
if you want to find the first occurrence or the last occurrence, that we will tackle separately. Okay, anyways, having said that, let's actually start coding now, right? So we have this okay, I have this visualization also, so this helps us in understanding the concept better. Reset. So this is a random array, right? And now I wanted to show you how it works. So whatever we have done, it's just an animation to do so. So we have 31 in the array, right? Let me just set the key as 31. Okay, and now when I will click on step, it will tell you, okay, low is 0, high is 15, middle is 7. So 0 plus 15 by 2 by that logic. Middle is index 7, and it is not 31. Okay, so now what do we need to do? 63 is the middle. 63 is the middle, right? But what's happening is it is greater than 31. So all these elements are now useless. So this is our element. So in the next picture, you should see this as high, this as low, and somewhere here as middle. Step. This is low, this is middle. It is still not 31, but this is lesser than 31. So we need to consider these elements now, right? Consider a key is found with index 5. Okay? This is a very good representation I found, so I'll just share it with you guys also, because it's pretty straightforward. I had another animation, but मेरे को खुद को ही समझ में नहीं आया उससे, तो मैं खुद कंफ्यूज हो रहा था, तो मैंने वो शेयर भी नहीं किया आपसे. ये मेरे को अच्छा लगा. ठीक है? So this I'm closing for now. Binary search. Okay, let's code it. What is it? What all do we know? We have left and right pointers. Calculate mid, move L and R based on comparison of array of mid and target, right? Based on comparison That's what we will do. Okay, so this is what we want to do, and what we are doing actually is we are setting some particular value of L and R, and then we are updating these values, right? And then we are repeating the whole thing again with the updated L and R values till either we get out of the condition, that means L becomes greater than R, or we find the answer and return the answer, right? So in this case, what we need to do is array sorted hai, target is present, write a function to search the target in nums. If it exists, return its index, otherwise return -1. Okay, so what's coming to my mind is that we should use a while loop. Why? Because when we are uncertain of the number of steps and we know the condition where we need to terminate, in that case while loop works fine, right? So we know the condition where we need to terminate. L becomes greater than R, terminate it. So keep running if L is less than or equal to R, right? And how should we assign L and R initially? It should start from 0 and it should go till whatever is the length of the array -1. Okay, so this name I don't like, nums. I just prefer my array being named as ARR. So int R is equal to array of length, sorry. This is the last index, which we generally call as n-1 index, right? So this is something that I've done while, although I've told you the condition, but let's still wait for the condition, right? Now we need to compare our middle element and the target element, right? Based on that, we will decide which particular subarray is relevant for us, right? So let's also make a mid variable here only. So now mid is equal to L plus R by 2. What am I doing? Right? If array of mid is lesser than target, this can happen. We will do something. Else if array of mid is greater than target, this can also happen. We will do something. Else if array of mid is equal to target, you can actually avoid using else if here, and you can just write it like this. Let me just comment this portion. You can write it like this also. Okay, and all of you know what this condition means, right? Array of mid is equal to target. That's the only condition pending. Okay, so now let's fill in the blanks, right? If mid is less than target, if middle element is in itself is lesser, all the elements to the left become irrelevant. So you need to set the starting point correctly. Okay, because till your 0, from your 0 till the middle, this portion is now irrelevant. So what was representing that position, what was present in that position, your starting point was present in that position. So you need to update that, right? So L is equal to mid plus 1. Similarly, if this is the case, what will happen is your middle element till the till the ending of your current subarray, that portion has just become irrelevant. So now you need to reset the ending point. You need to update the ending point, right? So update the end of subarray, right? So R is equal to mid -1. If this is the case, return mid. अगर एलिमेंट मिल ही गया, इंडेक्स रिटर्न करने को बोला उसने, रिटर्न कर दो. And if you are getting out of while loop, that means L has become greater than R, so return -1. So this is what I forgot who was asking, but yeah, this is what we will do. As soon as we are getting out of while loop, that means we did not get the element, we will just return -1. To me it seems pretty straightforward, but I will stop here for a minute or two to take your concerns, if any, and I'll just relaunch the poll. Okay, is this clear with code? Binary search, return -1. Yeah, that's it. Okay, poll. Okay, very impressive conversion. 88. It was 98. It is 88. Let's hope it stays there. Yeah. 87 हो गया, but 88 हो गया. Okay. So Very good conversion. Still, to address the other 10%, let's take 1-2 doubts, okay? Because it's natural to have doubt at this point. अभी code लिखा है, right?
यस सर.
क्या अनमोल?
सर आपने रिटर्न कराया -1, तो एरे में भी -1 है, तो इसमें थोड़ा सा कंफ्यूजन नहीं हो जाएगी?
नहीं.
एलिमेंट
आप बोल रहे हो ये -1 है ना?
यस सर.
हम क्या है ना इंडेक्स के पर्सपेक्टिव से सोच रहे हैं. See what he has asked us to do is return the index. If the element exists, don't return the element. Return the index. Otherwise, return -1. Because from an index perspective, -1 is invalid, na?
Yes,
That's
sir.
what it wants to say. -1 matlab index -1. That means we did not get the element.
Okay sir.
है ना?
Fine.
Sorry, you were saying something, Anmol?
Sir, fine.
Okay, cool, great. Yeah, Manoj, go ahead.
Hello, sir.
Yeah.
The array of mid is equal to target you wrote, right? The third condition.
Yeah.
Why didn't you put it in the first? Because if we find the target in the beginning itself, we can just skip the whole thing, right?
You are actually correct. Because what we want to do is we want to find the answer as soon as possible. So we can and we should do it. Let me take it into account. Logic wise, there is going to be no change, but yeah, we can do that. If array of mid enough.
Yes, sir.
So the one advantage of doing this is one advantage of doing this is when you will actually find the element, no, when your array of mid will actually denote the target element. In that particular case, क्या कर रहा हूँ मैं? In that particular case, this will help you. Why? Because at the first condition only, you will get the element and you will just simply return. It's not going to help you in the other iterations because this is anyways going to become false, right? Either this will be true or this will be true. So in that case, it will help you, but there is no particular advantage that we are getting by doing this thing. So it as keeping it below these conditions. And that particular case was better because most of the times we are going to have this only, right? But anyway, we are not going to go into microscopic calculations like this. Both have the same time complexity. Both are going to take approximately the same time, right? So just try to submit it and just be done with it. है ना? हो गया submit, ठीक है? And now I'll just take one more out because we have to move ahead also. Yeah, Ritik.
You have taken integer as mid. So what if the value of mid exceeds the value till an integer variable can store?
Acha. Okay. So
we should
I think you know the answer to it. है ना?
We should like we can do two
L
things.
plus R minus L by 2. That's what you want to hear, right?
Yeah.
Okay. I'll take it up. But yeah, logically you got it, right? L plus R by 2. I introduce it towards the later section because practically that doesn't happen, right? And I don't want to introduce more complexities at the beginning only. You are right. That is more appropriate way to approach this, but let's discuss it later towards the end. So yeah, got it. Thank you. Cool then. Binary search we know now. I hope it's clear to all of us. Now let's also try and understand that this same thing can be done recursively also, right? So let me here only. Okay, so let me write. This is the signature, right? Let me write. I'm going to write it here only. So let me say int binary search recursive. Okay, so this function I'm going to write, and let's try to code for it. What all things do we need? We definitely need the array and the target. But because we are doing it recursively, so you will realize this L and R also we need to pass. What do we do in recursion? We just update the input and start, or you can say solve the same problem again, right? In recursion, we just update the input, we just try to compress it, try to break it down to smaller input and just solve the same problem again. That's what recursion is. So what are the input parameters? the input parameters will be starting and ending point of the array, right? So that's also something we need to pass here. Okay, binary search recursive. Okay, so let's start with it. What are the few things that we know? First thing is when we need to return. So if L is greater than R, because if the search space in itself is invalid, that means you have already covered all the possibilities and you have not found anything. Just return -1 from here. If array of mid we don't know, so we need to define mid is equal to L plus R by 2. Sorry, L plus R by 2. If array of mid is equal to target, then return mid. These things though we should not be having any problem with. So see, I am just copying the whole logic from here only, from the top, right? If this is the case, we will consider it. So basically how I have converted it to the recursive way is, I have found out the base case. When do I need to start saying that I can't go any further? That's the base case. Iske aage nahi jana, right? That's the smallest input you can entertain. If L has become greater than R, that means जो one size के array आई थी उसके बाद भी cross हो चुका है मामला. That means we are not going to find anything any further. So that's the base case. Also, what's also a part of the base case, or what's also another condition that we are aware of? Element मिल गया, वापस जाओ. That's also something that's clear to us. Otherwise, if array of mid is greater than target, in this case what we need to do is we need to call, or you can say we need to solve for array of mid is greater than target. That means this side we need to reject, so we need to reset the value for R is equal to mid minus 1, है ना? Array of mid ही target से बड़ा है, right? So R is equal to mid minus 1. That is what you used to do, है ना? That is what you did here. Array of mid is greater than target, array of mid is greater than target, R is equal to mid minus 1, R is equal to mid minus 1. But to make a recursive call with this particular constraint, you can't do this, right? If you do this, it will, it might as well have become an iterative function. We are doing it using recursion. So what we want to do is we want to make a recursive call with this thing as input, information, that go and search for this recursively, but this time instead of searching in the whole window, search in the restricted window that I have given you. Okay, so if this is the case, what I will do is, first of all, I'll get rid of this thing, right? What I need to do is return whatever is the answer for this bs recur at target something. I'll just pass as it is. L this time is going to remain the same and R is going to become mid minus 1. Similarly, I think if you have understood this, you are not going to have any problem in what I'm going to explain next, right? If array of mid is less than target, what you're going to do is return at target. L is going to become mid plus 1, R, done. Okay, so those of you who are thinking once we come here, will we also go here? No, because this is an if statement inside of which what you see is a return statement. So you will not be coming to this one if you enter this, or if you have skipped this, only then you will come here, right? Something like that. So this way you are breaking your problem into half and ignoring the other half. First thing I wanted to tell you. And the second thing is, I have done return BS recursive for the smaller input, right? So what will happen now is a new binary search will start, or you can say this function will start getting executed from line 1 for the condition that L is equal to L and R is equal to mid minus 1. So this thing will get checked, this thing will get checked, this thing will get checked, and all of these things will happen, right? So let me relaunch the poll. Let me see what your inputs are. Hannah, is the recursive approach clear to you? And all you need to do inside of this is target 0. Yeah, let's try and run this. Cool. Sorry, what did I do? You can directly write this. So basically the problem is, let me say, let me just ignore this thing altogether, right? Why? Because we are only going to come here. We are only going to come at this point if this is also not the case, this is also not the case, right? So let's just try and run this. The problem is if you write a return statement inside of if, Java says that what if that condition is never met? In that case, you are risking not returning anything in a function that has a return type of integer. So either you can just add a dummy return 0 statement just for the sake of it, or you can do this also, because you know ये भी नहीं है, ये भी नहीं है, तो यही होगा ना, right? So now we are clear with the basic binary search. Okay. Now let's get to the problem which two of you asked, right? What if we have duplicates in the sorted array? How will we find the first occurrence, last occurrence of those elements in that case, right? अगर मेरी array ऐसी है 1, 2, 2, 8, 8, 12. Now I am not asking you to give me whether 8 is present in the array or not. I am specifically asking you. Let me make it more interesting. Right. I am specifically asking you to return me the first occurrence of 8. Okay. I am asking you to return me the first occurrence of 8. So very easy it is. Very easy. Still, if arr of mid, you only tell me. I'll open the chat for this one. You only tell me. Okay, I'm going to ask you one question. If arr of mid is greater than target, if arr of mid is less than target. देखो भाई, if arr of mid is greater than target, that means wherever your middle element is, that element plus all the elements to the right of it are still irrelevant. Even in this case, first occurrence of 8. If your current element is lesser than target, then that element and all the elements to the left of it are still irrelevant, right? The only change of code, the only change of approach will come when arr of mid is actually equal to target. In this case, you will consider if it is the first occurrence or not in some way. Okay, and I'm going to tell you how you will do it. But so far, just tell me, are you comfortable with this particular explanation? Abhi bhi, if this is happening, you are going to do the same thing only. The rejection of particular sub-array is still going to happen in the same way, right? Because same in the question, it's just that when you find the number, you have to make sure if it's the first occurrence or not. So you can say the special case will only come when you find that particular element. Other than that, the question is same only, na? Space complexity of recursive approach. Yeah, in that case, you are making log of n calls, right? So you can say space complexity for taking into account the recursion stack. Space complexity is also O of log n, right? Because the number of function calls you are making, based on that you will say the space taken, right? And you are only making O of log n function calls, right? So again, those who have doubts, please raise your hand. Yeah, Vipin, go ahead.
Sir, it is clear now, sir. I want to ask, sir, space complexity for recursive code.
Okay, great, very good. Okay, those who have a doubt, please raise your hand. I think Vipin, I asked, right? Naeem. Yeah, Naeem.
Yes. हेलो सर
हाँ
सर ये इंटीजर के लिए तो सर कर रहे हैं इंटीजर के लिए तो कर रहे हैं सर अगर हम कैरेक्टर के लिए करें सर कैरेक्टर को सर्च करने के लिए बाइनरी सर्च का यूज करें तो सर कैसे करना है
ऐसे करो, सेम एरे तो उन्होंने बना के दे दी ना, दैट्स देयर हेडेक. Implement the same thing. A is less than B is less than C is less than D. ऐसे चलता है लॉजिक. Similarly, A is less than, पूरा कर लो, Z is less than this. इनके एस का ही कोड्स होते हैं ना इंटरनली.
जी सर
सो उसमें ही लॉजिक है. मैं भूल जाता हूँ यार बार बार. इसका शायद 65 होता है एंड इसका 91 होता है क्या? लेट्स गूगल इट. आई एम वेरी बैड एट दिस. 97 होता है लोअर केस का. कैपिटल का क्या होता है? 65 है ना. तो आधा सही था आधा गलत. सो इस लॉजिक से उस लॉजिक से चलेगा ये. सो दे विल बी कंपेयर्ड बेस्ड ऑन देयर एस्काई वैल्यू. अपने को तो कोड में कुछ चेंज नहीं करना है ना.
जी सर जी ओके सर थैंक यू सर.
श्योर है ना. Okay, Naeem has asked. Sorry, Naeem. Okay. Any other doubts? Yes, official account. Go ahead.
Hi, sir.
Yeah.
Exactly, sir. I am unable to change my name. That's why I am still facing the problem to ask my questions, sir.
अच्छा.
Exactly, sir. हाँ मुझे ये पूछना था. मैंने बहुत जगह देखा है सर कि L+R/2 कभी कभी आउट ऑफ बॉन्ड हो जाता है. क्या बोलते हैं आउट ऑफ रेंज हो जाता है.
हाँ उसको दिखते हैं बस. अगर वही क्वेश्चन है तो छोड़ो. अरे देख लेंगे अभी. लॉजिक समझ में आ रहा है ना
सर? हाँ लॉजिक समझ में आ रहा है सर. और सर प्लीज मुझे अनम्यूट कर दिया करो सर बीच में, क्योंकि मैं बहुत बार मतलब फ्रॉम डे फर्स्ट आई एम स्टिल ट्राइंग टू आस्क सम क्वेश्चन. Exactly, I have a doubt in a linked list also, but I am unable to ask questions in a.
Okay.
Class, sir.
Okay.
Please, sir.
So please raise your hand on time as well, क्योंकि समझ रहे हो ना आप. We can only take limited number of questions in the class, but still I've taken it into account. What's your name?
My name is Naushad, sir.
Sorry.
Naushad.
Okay. Cool.
I dropped DM in Discord, sir.
Achha, I'll check it. You have dropped me a message on Discord?
Yeah.
You can send
Thanks
all your doubts there. I'll check it and answer there, because class में नहीं कर सकते ना हर बार. Okay.
Not an issue. Thank you.
Okay, yeah, Praveen, last doubt. Go ahead.
Sir, in the previous example, if we have 8 in the left side also, then how can we decide the first occurrence?
फर्क क्या पड़ता है? What's the difference? I asked you if this thing is clear or not. Praveen, you want do you want 8 to be placed there also? That's what you want, right?
Yes, sir.
I will do it, but I'm saying what's the difference? Approach will still remain the same only, right?
No, my question is, if the middle of the element is equals to target, and the leftmost element is also the target, then first occurrence how can we calculate?
Don't step ahead and think about the solution. I only asked you one thing: if this is clear or not. All the things that you are saying are very good, and whatever you just said is going to become the solution, is going to come right here. But in the flowing class, please make sure you are only answering what I am asking. Is this part clear? Yes or no? Right? So your observation is correct. Whatever you are saying is actually going to become a part of our solution. But okay, please only answer what I am asking. Okay, so cool. Everyone is clear with this, right? And today I have taken a lot of doubts because this is our first class. But going ahead again, if majority of you are clear with what I have discussed, I will have to move on by taking maybe 2 or 3 doubts because this time is precious. Okay, so let's move on. Now the problem is, or you can say the thing is, you have found the particular element. You have found that okay, this particular middle element is equal to the target, but you also want to make sure that this is the first occurrence, right? So what you will do here is, either it will be the first occurrence or it will not be the first occurrence. Based on that, we will do something. But your first problem is how to identify or how to say that it's the first occurrence. That's the question, right? How do we identify that it's the first occurrence? Very easy fix. Okay. First case is what who was I just talking to? What he mentioned, if ये जो element आपको मिला है, if it is the first element of the array only, in that case it's going to be the first occurrence of that element also, है ना? उसके पीछे तो कुछ है ही नहीं, so यही first occurrence है because it's the first element of the array. या तो ये हो जाए, or what's going to happen is array of mid is greater than array of mid minus 1. Sorry, very bad. Array of mid minus 1. या तो ये हो जाए. Why? Because see, your array is looking like this, right? 2, 8, 8, 8. If you are here, this is not the first occurrence of 8. So if it's not the first occurrence of 8, that means इसके left में भी 8 होगा. So this condition will not be true, right? So same for this one. But for this one, which is the actual first occurrence, if you move one step to the left of it, you will find that there is an element which is lesser than this 8. There is an element which is lesser than this 8, right? That means whatever repetition was going on, this is the first occurrence of 8. Because if we go to the left of it, we are finding something else. That's what is meant by the first occurrence, right? So ये तो, is it clear? Crystal clear. मतलब एकदम the same way you remember your name. Is it clear in the same way? I am opening chat for this. मतलब एकदम perfect. Okay, Shiv, you can raise your hand, Shiv. Okay, a lot of you have doubts. I can just repeat it, but till then, yeah, Dipanshi, go ahead. Arey, Kambar, you are raising hand in the chat. Raise hand in the Zoom, na? That we are. I forgot to unmute you every time because. Okay, so I'm going to repeat it. Okay, I'm not going to take any specific doubt. Our job is to find the first occurrence of this element. You have found one occurrence. Okay, it's a random. It can be anywhere. You are saying array of mid is equal to target. Now you need to make sure that this is the first occurrence. So either या तो वो element ही पहला हो array का, either this particular occurrence is the first element of array. 0 index, first element, or what happens is, let me write it this way, maybe it will become more clearer, or array of mid minus 1, that is the element जो अपने को मिला है ना, जो मैं बोल रहा हूँ कि मिल गया target, element that is just before it, mid minus 1, is lesser than this occurrence. क्या लिख रहा हूँ मैं? What it means is, if this is the case, it means that, take this scenario, right? This is how your array looks like: 2, 8, 8, 8. So basically, if this is the occurrence, the first occurrence, the number to the left of it is going to be different, right? क्योंकि ये first occurrence है, इसके left में 8 नहीं मिलेगा हमें. We will find a different number, and that number will be lesser क्योंकि भाई sorted array है ना, तो left में तो छोटे number मिलेंगे. So basically, if this is the case, in that case, we can say that, okay, we have found the first occurrence. So in दोनों cases में, we will just return mid. अगर ऐसा नहीं होता है, if this doesn't happen, so in the case of else, what we will do is we want to find the first occurrence. We want to find the first occurrence. Okay? और आपको पता चल गया कि ये first occurrence नहीं है. So what you will do is mid minus 1. R is equal to mid minus 1. Okay? This is what you are going to do. ये R है, वैसे मैंने बहुत गंदा R बना दिया. Why R is equal to mid minus 1 and not L is equal to mid plus 1? That's also one question you can have, you should have, right? So the point is, see, this is what I have checked. This is something I have checked. Because error of mid minus 1 is not less than error of mid, is not less than error of mid. What I'm going to have is, if this is not the case, that means there is an occurrence of the same number to the left also. So I need to go and consider that. That's why I'm making this shift. Is it clear? Let me take a poll instead of going through the chat, because otherwise we'll never be able to. Okay, I have relaunched the poll. Is it clear, this particular approach? Okay, very bad situation. So here we have a lot of doubts. I don't know what else to do other than to take your doubts here. So yeah, Dipanshi, go ahead. Okay. If you can't unmute, please don't raise hand. Yeah, Kambar.
हेलो सर.
Yeah.
हाँ सर, वो आपने 1 घंटा पहले जो बताया था सर, मिड कैसे निकालते हैं सर, वो मुझे अभी तक समझ नहीं आया सर. और मैं चैट में बार बार आपको सर लिख रहा हूँ, लेकिन आप मेरा मैसेज पढ़ नहीं रहे हैं.
चैट में हैंड रेज करोगे तो मैं पढ़ भी नहीं पाऊंगा भाई.
मैं सर टाइप भी किया था सर. और दूसरी चीज ये है कि आप जो सर बोल रहे हैं ना, बार बार पूछ रहे हैं कि क्रिस्टल की तरह क्लियर है या नहीं है, तो जब सब डाउट ही क्लियर नहीं हो तो क्रिस्टल की तरह कैसे मिलेगा सर आपको. और तीसरी चीज ये है सर, जो आप पोल बार बार लॉन्च कर रहे हैं वो सर सेम पोल आ रहा है, क्लास ऑन संडे और नॉट. समझ रहे हैं सर आप, क्लास ऑन संडे, ये पोल बार बार आ रहा है सर. आपने पोल चेंज नहीं किया है.
अच्छा, पहली बात, तुम कब से हो क्लास में?
मैं सर स्टार्ट से हूँ सर.
स्टार्ट से हो? तो मैंने जब पोल में नया बनाने गया था, so I said this that I am not able to create a new poll, so I am going to relaunch the same poll, treat it as the one where I ask, is it clear or not? First thing. Second thing, today, tomorrow, or in any class of module 2, I will not be able to answer if you just raise hand in the chat and not in the Zoom like you did this time. Okay? So that's the answer all your questions.
तो सर डाउट तो हमारा फिर डाउट ही रहेगा ना सर, फिर क्लियर कब होगा सर?
ऐसे करके हैंड रेज जो अभी किया, ये 1 घंटे से नहीं कर पा रहे थे?
नहीं सर, मैं चैट में कंटिन्यू भी लिख रहा था सर, कंटिन्यू भी लिख रहा था मैं. और अभी मैंने रेज हैंड भी किया सर बाद में. मैं पहले चैट में करा था, आपकी बात सही है, मैं वहाँ पे चैट में कंटिन्यू लिख भी रहा हूँ सर. तो
वही मैं बोल रहा हूँ ना, if you write it in the chat versus people who are raising hand here, whom should I give priority to? जो लोग यहाँ पे हैंड रेज कर रहे हैं वो ज्यादा हाईलाइट होंगे ना भाई, नेचुरल सी बात है. So why are we debating about this? Fine. From now on, if you have a doubt, raise your hand like this. Otherwise, there's a very high probability that it's going to get missed, because I don't get 1 or 2 messages. I get tens of messages. Okay. Now ask your doubt.
सर ये जो आपने बताया था स्टार्ट में मिड कैसे कैलकुलेट करते हैं सर, ये मेरे समझ में नहीं आया है. इवन के लिए और ऑड के लिए कैसे करते हैं?
Okay. So see, what's happening is, if this is an array, right? So 1, 2, 3, 4. So what I'm doing is I'm saying L plus R by 2. Okay. Why I'm saying this is, in this case, you can see by observation this is the middle, right? By calculation, what we want to do is we want to come at the middle of these two numbers, na? Are you agreeing? Even if I consider a particular sub array, I will go there later. But what I want to do is, if this is my L on the number line and this is my R, these are indices. I want to come to the middle of these numbers, these indices, है ना? So L plus R by 2 is going to give me that. I mean, that's the thing of how to calculate the mid. Let me explain it once again. So this is your L, right? This is your R. Now you want to come, this is the index, right? 0, 1, 2, 3, 4. These are index values. Now you want to come at the middle index. Middle index is the one which is going to lie exactly in middle of L and R. So it's just like taking average, right? To get in middle of L and R, you can just do L plus R by 2. That's how you're getting in middle. So this is for the basic case when you are just starting with the question. Let's take a more complex case, right? If this is your array, 0, 1, 2, 3, 4, 5, 6, 7 तक ले लेते हैं, right? 8 size array. Now what you want to do is, this is the portion that you are considering. This is the portion, okay? By observation, what you can see is this is the middle element. Now let's see if our L plus R by 2 logic is agreeing with that or not. I think you can do it now, manually.
Yes, sir. Now clear, sir.
2 plus 6 by 2. Now for even size array, I already told you there are two probable candidates. You will choose the first one. This logic automatically chooses the first one. If this is your array, ये वाला select हो जाएगा अपने आप. L plus R by 2 logic से.
सर अगर ओके ठीक है, थैंक यू सर.
हाँ ठीक है. Okay. So yeah, last I can't take. Okay, lot of time has passed, but I will have to take because you are not clear with this. Yeah, go ahead. And before I take,
sir, can you explain point with example?
Sorry, go ahead. Yeah, come again.
Can you explain point number 2 with example?
पॉइंट नंबर 2 कौन सा बोल रहे हो आप? ये
yes,
हाँ, मैंने एग्जांपल लिया तो था वैसे, बट मैं एक बार फिर से समझाता हूँ आपको ना. ओके, आर यू क्लियर विद द फैक्ट इफ माय मिडिल एलिमेंट इज ग्रेटर देन द टारगेट और लेसर देन द टारगेट, देन वी आर नॉट गोइंग टू हैव एनी चेंज इन आवर अप्रोच. इज दैट क्लियर?
yes sir.
ना?
Yes sir.
This is what I am asking. In this case, we don't have to change anything. We have to change something when we actually get to the target element. Now we have to find out whether we have reached the first occurrence or any random occurrence. ठीक है? Agreed?
Yes sir.
Yeah. Okay. So now that I have reached a particular occurrence, either what is the way to determine that that's the first occurrence? This is the first occurrence. Okay, this is the first occurrence. The way to determine this is the number that's coming before it is lesser than it because it's different from it, right? That's what is making it the first occurrence. So basically, air of mid minus 1 is less than air of mid, right? है ना? यही थी सेकंड कंडीशन. फर्स्ट कंडीशन क्या थी कि इसके पहले कि आप ये सब करो, बिफोर यू गो ऑन एंड कीप डूइंग ऑल दिस स्टफ, यू नीड टू फर्स्ट चेक इफ दिस इज द फर्स्ट एलिमेंट ऑफ द एरे.
कॉन्सेप्ट आ रहा है
क्या
सर इसमें? फर्स्ट अकरेंस का कॉन्सेप्ट क्या आ रहा है? ये तो ये कह रहे हैं आप कि अगर मेरा कोई नंबर फर्स्ट अकरेंस पे मेरा मिड ही हो, इफ इट इज जस्ट द मिड, then it is fine. Else you are giving a set of array in that there will be chances of mid. So next way is to again traverse for the whole half set of array, and after on just till I get the exact value what I want. इसमें फर्स्ट अकरेंस का आ रहा है, फर्स्ट अकरेंस तो मेरा एक ही में आ रहा है.
आई एम नॉट getting your question.
And the value is what I want.
I'm not able to understand what you are asking.
Sir, I'm saying when you are writing array mid minus 1 less than array mid.
Yeah.
That's defining whether.
do one thing, please write your query on the chat because it's taking a lot of time and I'm not even able to hear you. Okay. So I'm going to allow you guys to chat. Please write your query there. Okay. Yeah, Namrata, last doubt I can take. Go ahead.
Sir, I'm audible.
Yes.
Hello. Sir, I didn't got that else part, so could you please explain it once again?
Okay. Let me go step by step. You got this?
Yes, sir.
Pakka?
Yes, sir.
So now the point is, once we are reaching a particular element, we are now trying to identify if this particular occurrence that we have found, is that the first occurrence or any random occurrence, right?
Okay.
Now, this is the way of making sure that this is the first occurrence. Do you agree? I
Yes,
just
sir.
explained it to the previous guy also. है ना?
Yes, sir.
Now, if this does not qualify, or if you find out that okay, this is an occurrence, but it's not the first occurrence, right? In that case, can you say that the first occurrence lies left of mid?
Yes, sir. Yes, sir.
पक्का?
Yes, sir. Okay.
है ना?
Got it, sir. Got it. Yeah.
ठीक है?
Yeah. Thank you, sir.
Okay. Cool then. So let me do one thing now, okay? Because we have spent a lot of time. I have explained it twice. Let me try and code this, and then if you still don't get this, then we can come back here. There is one question on this on AccuJob. So let's go here. Floor in sorted array नहीं. Searching a number. इसमें इन लोगों ने क्या बोला हुआ है ना? Given an array, this. Your job is to print the position of first occurrence of k. इन लोगों ने वो बोला हुआ है ऑलरेडी जो अपन सॉल्व करने का ट्राई कर रहे हैं. सो व्हाट आर दे सेइंग? nk array. ओके. सो अरे यार बहुत लिखना पड़ता है. न्यू स्कैनर सिस्टम डॉट इन. ठीक है. int n is equal to sc dot next int. ठीक है. For the target is equal to sc dot next int. ठीक है. ओके. फॉर लूप चला के इनपुट ले लो. int I is equal to 0. There's an n I plus plus. This portion I'm not going to explain to you. I'm not explaining this, and I'm not going to explain because I'm just taking the input of array. This is something that if you don't know, learn it from Google and then come back. Okay, because it's something that has been done a lot of times and we can't take it up again. Okay, so sc dot arr is equal to new int. ठीक है. n sc dot arri is equal to sc dot next int. Cool. This has been done. Now I have this array. Now this is binary search we are talking about. So we will have to trust these guys that whatever array they have given is already sorted. Now first occurrence, right? So let's make a function inside the main class only. Static binary search. ठीक है ना? Let's take the input. ठीक है. Now they are asking us to find the first occurrence. I'm going to copy paste the code of binary search just to kind of prove it to you that there is nothing different than what we have done in binary search. So this code we have just submitted it. Copy paste. Control C. Control V. Return type. Control V. Int L is equal to 0, R is equal to add dot len mid हो गया, this mid is this, if this. Okay. If mid is equal to target, in this case we need to do something, right? Find out if it's the first occurrence. है ना? So either it is the first element of the array only, so either this or air of ठीक है. If this happens, ठीक है, else okay, this thing I'm doing, else if return -1 करना है क्या? The first print the first position, else print -1. हाँ, इनके पास भी है -1. ठीक है, so ये कर लिया. Now what we'll do is system dot out dot println binary search ठीक है. Let's see if this particular thing works. Control C, Control V, run code, and I'll open chat for you guys. यही है क्या? Okay, we are wrong. What do you want? 1, 2, 3, 4. अब so they are asking us for the position, not the index. That is something. क्या ही बोले? ठीक है, जैसे जिसकी सोच. If ऐसे कर लो यार, ऐसे कर लो. ठीक है, दिस इज if answer is not equal to -1, ये बहुत ही सस्ता तरीका है. इसके और तरीके से भी कर सकते हैं अपन. बेसिकली क्या है ना, दे हैव आस्क्ड अस टू प्रिंट -1 या तो पोजीशन. अब देखो ना, इसका इंडेक्स क्या है नॉर्मल लोगों के लिए 0, 1, 2, 3, जो कि अपन का सही प्रिंट हुआ है. बट व्हाट दे वांट अस टू प्रिंट इज 4, जो कि पोजीशन है, फर्स्ट एलिमेंट, सेकंड एलिमेंट, थर्ड एलिमेंट, फोर्थ एलिमेंट, लाइक दैट. सो अपन उसको +1 कर रहे हैं, अदरवाइज वी आर रिटर्निंग -1. और लेट्स डू वन थिंग, अपना फंक्शन ही चेंज कर देते हैं अपन. कहां गया? Where is the function, भाई? This is the function. This is return statement से change कर दो हर जगह. Return mid +1. Return mid +1. एक ही जगह कर रहे हैं अपन रिटर्न, राइट? Return -1. So ये सब टाइम पास नहीं करना पड़ेगा हमें. What we will just say is, we will just say print this. Sorry, है ना? So this is not something logical. इसमें कुछ खास अपन ने लॉजिक चेंज नहीं किया है, but you know, this is just the format in which they want the output. 4 आ गया, ठीक है. Let's try to submit this. एक सेकंड, एरर सॉर्टेड नहीं है. अबे माय बैड. ओके, आई शुड नॉट हैव ट्रस्टेड इट. मैंने बोला बाइनरी सर्च का क्वेश्चन है तो ट्रस्ट कर लो, पर ठीक है. एक सेकंड ना, ये हो गया. लो, अब कर दो. शुड वर्क फाइन. अरे वाह. अबे यार, सॉर्ट पे पोजीशन विल चेंज. मैं नहीं कर रहा ये. अब इसमें हैश में अब लगाओ, मतलब क्यों? I will tell the error. मैं क्या कह रहा हूं ना, हम लोग शायद समय से आगे का सोच लिए. क्या पता ये बाइनरी सर्च का हो ही ना. क्या पता ये लोग चाहते हो कि हम लोग एक फॉर लूप चला के कर दें इसको, है ना। अब अपन वैसे करेंगे, n is equal to add.len. They want the first occurrence, we will give them the first occurrence. And आते मैं पढ़ता हूँ चैट एक बार, चैट तो नहीं पढ़ पाऊंगा, 43 हो गए पार्टिसिपेंट्स जो हैंड रेस कर रहे हैं, आते हैं, एक सेकंड ना। एरी सॉर्टेड नहीं है इनकी, बताओ। n is equal to add.length, this हो गया। Now if add of I is equal to target, return I plus 1, इनको चाहिए पोजीशन। अब क्या हो गया भाई? अरे हाँ, सॉरी, हाँ अब सॉर्ट नहीं करना है, सॉरी, माय बैड। अब तो सॉर्ट नहीं करना था, माय बैड। नाउ आई एम वन स्टेप क्लोजर टू अ ब्राइट फ्यूचर। भाई साहब, ये क्या था, पर ये मतलब या तो मैं कुछ गलती कर रहा हूं बहुत बड़ी, या तो ये क्या है ये, मतलब टाइम पास बिल्कुल। फाइंड द फर्स्ट एंड लास्ट पोजीशन ऑफ एलिमेंट इन अ सॉर्टेड एरे, ये जो नॉर्मल लोग सॉल्व करते हैं वैसा क्वेश्चन, ठीक है। तो फर्स्ट अकरेंस तो हमने देख लिया, ओके। वी हैव सम टाइम, लेट्स आल्सो लुक सस्ते नशे, लेट्स आल्सो लुक एट कैलकुलेटिंग द लास्ट अकरेंस। सेम चीज ही है, बट आई टेक सम डाउट्स नाउ, ओके। या गो अहेड दीपांशी।
एक्सक्यूज मी सर। सर जैसे आप कर रहे थे कि बीट को हम चेक कर रहे हैं टारगेट से कि वो फर्स्ट अकरेंस है कि नहीं है।
हाँ
सर, इफ की टारगेट हम ऐसे ही पढ़ते आ रहे हैं ना कि जो हमारा बेटर केस होता है कि सबसे पहले हम मिड चेक करते हैं।
मैं समझा नहीं, हम लोग क्या करते हैं सबसे पहले?
हमें जब हम कॉम्प्लेक्सिटी चेक करते हैं तो
हाँ,
तो बेटर केस हम यही चेक करते हैं ना कि मिड टारगेट पे मिल जाए, हमें टारगेट मिड पे मिल जाए।
नहीं, वर्स्ट केस करते हैं ना अपन तो टाइम कॉम्प्लेक्सिटी में। व्हाट डू वी वांट इन द वर्स्ट केस? if this logic runs for the maximum amount of time, even then it's going to get finished in log of n time. समझ रहे हो?
फर्स्ट केस के साथ उसको कंपैरिजन कर रही हूँ कि सबसे पहले हम मिड चेक करते हैं ना बाइनरी सर्च में।
Oh, I told you, right? How does it matter? देखो, these are a set of if and else statements. Does it matter in which order you are putting it? If this happens, do this, else go to that. इनको अगर आप फ्लिप कर दो, if और else को, कोई फर्क थोड़ी ना पड़ेगा। पहले कौन सी कंडीशन चेक करो?
पर फर्स्ट अकरेंस का तो हो जाएगा ना कि उसने सबसे पहले जो हमने कंडीशन लिखी होगी वो उसी को चेक करेगा और उसी को रिटर्न कर देगा।
अपन देखो ना, we are going to get inside this block add of mid is equal to particular element. When that's the case, we are only going to get inside of it when we will get that occurrence, है ना? Once we get inside it, तब तो हम कर ही सकते हैं ना ये। I am not getting your point. Once we realize that okay, this is one of the occurrences of that target, at that point, if we find that it's the first occurrence, we can return it. If it's not the first occurrence, we can update the value of our variable, the right variable, right?
फॉर एग्जाम्पल हमने मिड इज इक्वल टू टारगेट लिखा और वही मिड हमारा टारगेट है,
तो वही मिड हमारा फर्स्ट अकरेंस है, ऐसा?
हाँ जी फर्स्ट अकरेंस हो गया ना वो।
ठीक है ठीक है, तो
मतलब वो मिड को फर्स्ट अकरेंस डिक्लेयर कर देगा।
मिड को फर्स्ट अकरेंस डिक्लेयर करने के लिए बोथ दीज कंडीशंस, आइदर ऑफ दीज कंडीशन शुड बी ट्रू, है ना? Yeah, Shikhar, go ahead. So we have anyways reached towards the end of the class. I'll just explain this and be done with it. But yeah, go ahead, Shikhar. Or Shikhar, we can do one thing. Okay, I'll just mute you back. I can explain you how to find the last occurrence. We can try to code it. It will take 5 minutes over 11 p.m. Then I will stop for 10:50. I'll stop recording everything. Class is over. Whoever wants to drop can drop. After that, I will stop for 10-15 extra minutes. Then you can ask your doubts. Okay, this we can do. Right. So first occurrence, almost everyone. Okay, okay. That I don't know. Right. I'm assuming that you got it. But yeah, assuming you got the first occurrence part, let's solve the last occurrence. Let's solve for the last occurrence. Right. So for last occurrence, what we are going to do is, if array of mid is greater than target, if array of mid is lesser than target, still the same. If array of mid becomes equal to target, then we need to find out if that's the last occurrence or not. And जैसे हमने देखा था, क्या किया था? या तो ये एलिमेंट ही फर्स्ट एलिमेंट हो जाए, सो या तो ये एलिमेंट ही लास्ट एलिमेंट हो जाए, और दिस इज और प्रोग्रामिंग वाला और है ना, और the element which is coming after it is greater than this element, है ना? So arr of mid plus 1 is greater than arr of mid, right? In this case, doing arr of mid minus 1 will not help, because if you have a scenario like this and you are standing here at the last occurrence, checking this does not make any sense, no? We are anyways expecting कि यहाँ पे तो 8 हो ही सकता है. Since this is the last occurrence, there can be an 8 before it. But what we want to make sure is there should not be any 8 after this. Right? So this particular one should be greater than array of mid. And for those of you who are still confused, the main point is it should be not equal to array of mid. Right? It should not be equal to this target that we have found. Right? That's what we want to do here. So let me code this particular approach. What we can do is we can make two different functions, and then we can utilize those functions to return inside our main thing, right? So I'm making one function as first occurrence. You know, we will see whatever parameters we need. Another function for last occurrence. Okay, because see, logically there is nothing. But the thing is, we will have to write different logics for it, right? So I'm making different functions only. So what I'll do is first occurrence, right? Let's go to binary search. Control C, Control V. ठीक है. L is equal to 0. R is this. Mid. L is in R. This. Okay. So if mid is equal to target, in that case, what is this? How did I get this thing correctly? Which question is this? Whatever. This is already correct. Yeah, let me just. ऐसा होता binary search, right? Else if this. Okay. Now what we need to change is, if array of mid is equal to target, in that case what we need to do is we need to check if it's actually the first occurrence. So if mid is equal to 0 or array of mid is less than array of mid minus 1 is less than array of mid, in that case we will return mid. But otherwise r is equal to mid minus 1, because I am once again explaining you, if this particular occurrence is not the first one, then the first occurrence lies to the left of it, है ना? इसलिए r is equal to mid minus 1. अगर ये first occurrence ही होता तो हम return कर जाते ना, और ये occurrence है कोई any particular occurrence तो ये है, मतलब कुछ तो ये है, because mid is getting equal to target, right? So at this point you can also write target, because arrow of mid is nothing but target at this point, right? You are coming inside this if condition. Okay, then same thing we are going to control C, control V, and what we are going to do now is we need to find the last occurrence, right? So either mid is what, n minus 1, right? Let's declare what n is. And or what's the other possibility? Mid plus 1 is greater than target. Okay, mid plus 1 is greater than target. This, otherwise not this. Let me justify why I am writing this. Okay, or if it's even correct or not. ये तो मैंने randomly change कर दिया. ऊपर r is equal to mid minus 1 हो रहा था, तो यहाँ पे l is equal to mid plus 1 कर देते, ऐसे ही मस्ती में. But let's see if it's even correct or not. If we are standing at an occurrence of target that is not the last occurrence, that means there are still more targets. मतलब अगर मैं यहाँ पे खड़ा हूँ, if I am standing here like this, 8 is there and there are some more 8s after it. I am standing here, this is not the last occurrence. That means अभी और 8 आने बचे हैं to the right of it. So what I will do is, ending I will do wherever I was doing, but starting point I will change from wherever L was to L is equal to mid plus 1. Because in this sub array that I am now assigning, you can say that I am not now changing my problem size to, in this sub array I will find the last occurrence. Okay, so this I have done, seems fine. You actually have to return it in form of an array. So end ARR, or let's call it the answer array. This I am going to change to ARR. Okay. Okay, int answer array is equal to new int size 2, है ना? Answer of 0 is going to be first occurrence, ना? तो first occurrence, और इसमें क्या पास करना है? देखो, हम लोग ARR यूज कर रहे हैं, हम लोग टारगेट वेरिएबल यूज कर रहे हैं, राइट? सो ये पास कर दो. Answer of 1 should be equal to last occurrence, again ARR target. ठीक है, ये सिग्नेचर इधर से कॉपी कर लेते हैं. कंट्रोल C, कंट्रोल V, कंट्रोल V. ओके, ठीक है. Let's see if it's going to work or not. For this case it did. Let's use example test cases. Let's try to submit it. It's working. Acha, one thing that I did not ask you guys, but I directly did. So my reason behind copy pasting from binary search was to prove to you that this is nothing different. But like does it kind of hinder your way of learning? मतलब मेरा इंटेंशन तो ये था कि मैं तो आपको ये प्रूव करना चाह रहा हूँ कि बहुत आसान है, बट इज इट वर्किंग इन द ऑपोजिट डायरेक्शन? ऐसा तो नहीं हो रहा कि समझ में नहीं आ रहा उस वजह से? आपने नो बोला है, मैं क्वेश्चन भूल गया मैंने क्या पूछा था. इज इट क्लियर दिस वे? डॉक का लिंक आप अभी ले लो. कंट्रोल C, कंट्रोल V. फाइन, यस यस यस. टाइम कॉम्प्लेक्सिटी वही विकास, वही लॉग इन. थोड़ा सा एक दो स्टेप इधर हो रहे बट लॉग इन ही है. मिड माइनस 2 कैन ऑल्सो बी फर्स्ट अकरेंस. आर वी चेकिंग दिस एज केस? अशफाक, अपन ये नहीं जानते ना कि वो कितनी बार आ रहा है. व्हाट इफ इट्स अकरिंग यू नो थ्रू आउट द एरे? व्हाट इफ दिस इज योर एरे, समथिंग लाइक दिस? इफ आई गो टू द कंसोल and this is my array. Target is 5. ठीक है, I mean, we can't hard code it like that. इसमें तो ऐसा ही आ गया. Can I share lead code problem link? हाँ, अरे if you don't know अभी so far, Praveen, even on the lecture codes doc, no, what I do is let me just show you only. Explain करने में time लग सकता है. So basically, let's say this problem we did from lead code, right? So I've already pasted the link here, attached it as a hyperlink. So this is one thing. But yeah, so I did this in my previous batches. There is another document that I share, which is called as questions repo document. So there I do nothing. I just add the links or the names of the question that we solve in a particular class. There is only one advantage to it. When you are revising and you don't want to go through this large code document, you can directly go there and see what questions we have solved throughout the course. So that kind of makes it easier for us to revise. So I'm stopping the recording now because we are